Just always saying the same thing. This is just checking my microphone. See if it's working at all. Okay, so we have this file. It's OpenBCI file that we opened like in, was it 10, I don't know, 1 minute in Python. This is what it looks like. This is obviously there's obviously nothing on what's it, channel 2, 3 and the rest. I mean, there might be something there. Yeah, when you have things like that, can I, this is not it's not JavaScript, so I can't zoom in and out. A range. Zoom over there quickly. No, there's nothing there, is there? Just a flat line, so we can get rid of it. And just look at was it 0 and 1? There's essentially no other data in this particular file, so it's a text file. It has a header, the first 5 lines is header, so I printed it out here. The file can record the 8 channels, sampling rate of 250. It's the board being used, OpenBCI board, Wi-Fi something. It doesn't really matter. Let's do range 2. Close this window. Should have another one open. Right. So that's what we have. Okay. Yeah, it's a major first thing that comes to mind is a major DC shift. So I would say yes, we can filter it out quickly. But yeah, there's something wrong in the recording, so it should be unusable essentially. It's meant to be 10 sampling rate. We can ask, can we correct the x-axis to show time instead of number of samples? So I don't know if it can do it. We have GPT-4 open as well, but I don't think we need it. It's pretty straightforward. Yeah, the sampling rate. So yeah, I don't want it to be taken. So the reason I'm doing it, there's a general. We might actually have a more general tool, ideally in JavaScript. That you can load your data and will display it for you, do some sort of analysis. You know, mainly looking at the signal quality, amplitudes, things like that. So this that we just open it quickly in Python. Yes, in theory, OpenBCI have their own Python library, but I don't want to use it because I want to make the tool generic so it can take any data. So we just want to use a NumPy, Matplotlib, pandas if necessary. Currently not using pandas, using Matplotlib to plot. can actually compare it to pandas, but ideally we want to take it to JavaScript. So it will be a standalone tool. So I don't know if we should continue with this or not. Anyone has any questions? So in theory, yeah, a file like this. So yeah, major DC shift is some major artifacts. Interestingly enough, the DC shift continues after the artifact. So I suspect there's just something really wrong with this file. So would be interesting to see. So yeah, so when you record, you need the signal to settle. So if you're trying to get your baseline, ideally we need to record for long enough to see what happens after a longer period of time. There's something really wrong if it didn't settle for 10 minutes. There could be a major shift, DC shift, so indicating that something is wrong with the recording, as in really wrong. The electrodes might need to be reattached or things like that. Yes, we can do the time as well. Comment this out so we have the actual time of the recording on the x-axis, the sampling rate of. So currently we have the number of samples, and here it is. Should show us time in seconds, and yes, this is 10 minutes. So yeah, if the baseline didn't settle within 10 minutes, it's no good. In this case, yeah, if you can make the recording better, there's a DC drift that yes, we can filter. Now if Copilot can just do it, yeah, we'll leave the high frequencies for now. This drift is obviously low frequency components. Okay. So it's taking the mean. That's won't do it, would it? Okay, mixed up with the axis as well. And we can try it out. I'll do it before. It's over here somewhere. So we're changing the data. We're plotting the data as well. We're trying to convert string to float. So first it was meant to be float the numbers like here. What are filtering libraries? Yeah, using a high pass filter. SciPy. That looks more like it. Yeah, order 5, it's fine. This is returning the yeah, what are they called? The coordinates of the filter. It's the coordinates of the filter. It's not actually being applied. And this is actually using the filter, returning y. Order 6, not this already order 5. What is it trying to do? Didn't we this cutoff is not there. 5 is default, but then we're actually using 6. Okay, it doesn't matter, 5, 6, it should be the same. It should not see much different. Get the filter coefficients. Now we're using the function, getting A and B. Then we should be using the button high pass filter function. Filter the data. Wait a sec. That's just turning it into numpy, into a float, and applying the bandpass filter. So that's okay. Can convert string to float. String type. Can I fix it for us? There is actually the error is actually elsewhere. I'm just trying to filter that signal, but yeah, even without filtering, can tell there's something really wrong with it. There is a major DC shift. Right, so we converting columns to floats. All right, because of the timestamp. Right, It's mixing because I have pandas. It's mixing in pandas. Do I actually have to do it? Yeah, will be a mix of stuff. And can it go there somewhere? What? It's not a datetime string. Yeah, the time column. You're going into a wormhole. It's not 22, is it? The timestamp, number of channels, sample rate, board, sample index. What's the timestamp? Ah, it's the last. The 2 timestamps. Why? One regular and one formatted. It's a bit odd. There's a year and date. Can get rid of it. We don't actually. Yeah, we don't need the timestamps. Can we tell it? Don't worry about the timestamps. Yeah, we can just use the sampling rate. It's rewriting the whole code. Right. Yeah, so we have first lines as the header, the rest is the data. Channel names. It's standard filtering. I don't know why we need sampling rate twice. We can fix it later. Right, so we had GitHub Copilot writing the whole code. Would it also? No, I'm getting the same. Pretty sure. ChatGPT somehow always does better. But pop this code in, give it the error. It will just most of the time it's able to sort me out.
Alright, let's get into this. The error you're encountering is because there's a string in your data array that can't be converted into a float. Specifically, it's trying to convert a timestamp, the 8th of February 2024, 13 hours 22 minutes and 58 seconds, .184, and obviously, that's not going to work as a float. This issue probably arises because the data you're trying to process includes both numerical EEG data and non-numerical information, like timestamps. When you use data equals NP, array, data, 1, dtype equals float, it attempts to convert everything in your data array to floats, which is causing the problem. To fix this, you need to make sure you're only attempting to convert the actual numerical EEG data to floats, not the timestamps or other non-numerical data. Here's how you can do it. When reading the data lines, skip the non-numerical columns, like timestamps. Then, convert the remaining EEG data to a NumPy array of floats. Let's modify the code to address this. This approach skips the first column, assuming it's the timestamp, and only processes the actual EEG data. Give this a try and it should resolve the error you're facing.
Can we give it the sample? Because this is the sample of the dataset. Which columns am I ignoring? The first column is sample index, and it seems like the last two columns are the timestamps. Sorry, the last three columns. So yeah, the last column is the string that we can convert or just ignore. How to modify the code. Yep.
Got it. Thanks for sharing a sample of your dataset. Based on this, it looks like your dataset has multiple columns with different types of data. Specifically, you have sample index, a numerical index for each sample. EXG channels, 0 to 7, these are your primary EEG data channels. Excel channels, 0 to 2, accelerometer data, which might not be relevant for EEG analysis. Other, several, other, columns with unspecified data. Analog channels, 0 to 2, additional channels, possibly for other types of sensors. Timestamps, 2 columns at the end for timestamps. For EEG analysis, you're probably most interested in the EXG channel data. The accelerometer, analog, and other channels, along with the timestamps, can be ignored for now. Here's how you can modify your code to focus on just the EXG channels. When loading the data, only select the columns corresponding to the EXG channels. Ensure all other columns, like timestamps and accelerometer data, are ignored. Here's the updated code. This code snippet will extract only the columns related to the EXG channels, which are typically the ones of interest for EEG data analysis. It skips the first column, sample index, the Excel channels, the other columns, the analog channels, and the timestamp columns.
Right, so so instead of this line, have needed after the high pass filter. After this, do functions. Remain the same. Right, so that's the filtered bit. Looks like the filter is ringing. Let's see. The other good thing about GPT-4 is that you can just pop in the output. Looks like the filter is ringing. Also, can we create a chart with two panels, one for the original unfiltered signal and the filtered waveform below? How to change the code to do it? Yep. Anyway, I think that filtering might be a bit too aggressive.
The plot you're seeing indicates that there's a significant transient response, often called ringing, which can happen when filtering data, especially with a high-order filter and a very low cutoff frequency. This is likely an artifact introduced by the filter itself, and not actually present in your original data. To create a chart with two panels, one for the original unfiltered signal and one for the filtered waveform below, you'll need to plot subplots in Matplotlib. You can do this by using the subplot function. Here's a modified version of your code to do that.
Generating the code.
This code will generate a figure with two subplots. The top one will display the original, unfiltered data, and the bottom one will show the filtered data. You will also see titles for each subplot to differentiate between them. As for the filtering issue, you could consider using a lower order for the filter, which would reduce the ringing. Another option is to apply a zero-phase filter using Skippy signal filter instead of L filter, which avoids phase shift and can reduce transients. Here's how you could modify your butter_high-pass_filter function to use filtfilt. Try these adjustments and see if the resulting plots are more to what you're expecting.
Right, well, I'll have trouble integrating all that. Can you either generate the whole code without any placeholders, or give me prompts for GitHub Copilot to change the code, whichever one you prefer? Yep.
Sure, let me provide you with the complete code. This will read in your data, apply a filter, and then plot both the original and filtered signals in two separate subplots.
Yeah, so it's giving me the whole code. I mean, we can close GitHub Copilot for now. Yeah, the GitHub Copilot, the GitHub, the ChatGPT. One's a Copilot, one's a GPT. Okay. Giving you this, the window is not scaling properly.
Make sure you replace path underscore your underscore file.txt with the actual path to your EEG data file. This script will read your OpenBCI text file, isolate the EEG channel data, apply a zero-phase high-pass filter to the EEG data, plot both the original and filtered EEG data in 2 subplots. Regarding getting help on GitHub, you can search for repositories related to EEG signal processing or OpenBCI. You could use search terms like EEG signal processing GitHub or
Okay. That's okay. Yeah, we don't actually want to use the OpenBCI Python library. Well, because we want to make this thing as generic as possible and potentially eventually have a tool on the website to allow you upload your own data. But ideally I would like to try making it in JavaScript. And yes, JavaScript has some AI as well. What's the AI doing? It's coding. This is better. This interface is still, yeah, people screaming at me for using GPT-4 like this. But it's actually better. It can hold longer context. I mean, GitHub Copilot was really good at, so we generated this code now from scratch. It's opening this EEG file that someone recorded 10 minutes of quick and dirty EEG. You might close it. I think there's any. So there's a question of if I record on battery and filter the signal, so that's already filtered the signal. Yeah, the filter is a bit too aggressive, so we currently trying to make it less aggressive. High pass, or we can reduce the order of the filter, will make it less aggressive because it's currently ringing. And we're also now plotting 2 separate subplots, one with the original data and one with the filtered data. Regards the battery question, I don't know. I don't think it's a battery problem. There is a DC shift. It's horrible. It's like and it's going over like the whole 10 minutes. Let's see if this code works. Then I can actually create quickly a copy. My Git is not currently working properly. So I said wrong. So I'm just using the old good version control of just naming the files, renaming the files. It stuffed up the folder name. Not good. Yeah, most of the time dealing with this. I had this weird thing on, so I'm using Ubuntu, right? And Visual Studio Code. I think there's something wrong because sometimes when I hit the Control E shortcut, it just literally puts an E in the code. I'm pretty sure it's I'm pretty confident I'm pressing that control button. Right, so that's so I don't know if the person who sent me the data is watching or not, but Yeah, so the ringing is okay. Now, problem with this filter, it actually removes way too much. and it's ringing. But that's the original data. There's a major DC drift. So I don't know what's up with those amplitude. It doesn't really matter because oh wait, it actually might matter. We had to can we, before filtering, would you recommend doing the trending first before applying the filter? Because the amplitude is this at this crazy minus 15,000, minus 2,000. Also, can you explain DC drifts, why they are happening and how to potentially deal with them? In this particular case, the DC drift is happening over entire 10 minutes of recording. And I shared the recording as well, the raw and the filtered. The filtered is just ringing, so hopefully that detrending will help. Detrending. It won't get it, would it? Come on. Let's turn off that microphone. Detrending. I'm doing detrending. It should know what it is. It's common. Before applying the filter, because the amplitude is crazy. Yeah, minus 2,000. So I can explain a baseline. Explain baseline DC drift. So I don't think there are battery related, if that's what the question is. I'm pretty sure the battery won't change much, but can try. But yes, it's some basic. I think it's to do with how the electrodes are being placed. So essentially, you need to monitor. So ideally, before you start recording, you monitor impedance. So you monitor the how well the electrode is connected to your head. Also, could you mention monitoring electrode impedance when recording EEG and how it's important or not? Yep. So I'll close there. See what it says. The thing about, where's my, oops. Try another voice.
Detrending before filtering can indeed be a good idea, especially when you observe a slow drift in your data that isn't related to the actual signal of interest. This drift is often referred to as baseline wander, or DC drift. It can be caused by a number of factors including electrode-skin contact. Imperfect contact between the electrodes and the skin can introduce low-frequency noise into the EEG signal. Body movement. Even slight movements can cause changes in the electrical properties of the skin and the electrode interface, leading to drifts. Environmental factors. Temperature changes and equipment instability can cause baseline drifts. Physiological factors. Breathing, sweating, and heartbeat can all impact the baseline level of the EEG signal. Detrending removes these low-frequency trends without affecting the higher frequency components of the EEG signal that usually represent the neural activity. In practice, detrending can be as simple as subtracting a moving average or fitting a polynomial to the data and then subtracting it. For EEG data, a simple linear detrend is often sufficient, which can be done using Skippy, signal, detrend.
Skippy.
Here's how you could add detrending to your code.
Yeah, so try to detrend first, so this will just turn the values, move them to around 0. That's all it does. So we have from Cyber Signal import the trend as well. Not currently being used. The riff. I don't like coding. To restructure this code. The messages in LinkedIn Live are just horrible. They disappear on me. So there were like 7 comments, but I can only see the last one. I don't see them in the chat at all. Yeah, LinkedIn for streaming is, yeah. Twitch is really quiet, and YouTube quiet as well. Anyway, I might keep this one short. Just finish this quickly. Let's focus on that. Actually listening to what's said.
Detrending before filtering can indeed be a good idea, especially when you observe a slow drift in your data that isn't related to the actual signal of interest. This drift is often referred to as baseline wander, or DC drift. It can be caused by a number of factors including electrode skin contact. Imperfect contact between the electrodes and the skin can introduce low frequency noise into the EEG signal.
Yeah, so I don't know why, but most consumer grade devices don't even bother recording it. It's absolutely important to record your impedance, so you know what it tells you what's the quality between the electrode and skin connection. It might be not sitting well. You might need to reattach the electrode. Yeah, depends. Generally, as if the electrode is not well attached, you will start seeing more mains harms or whatever. If you 60 hertz, if you're in the United States, 50 hertz if you're in Australia. I'm not sure about other countries. Body movement, yeah, that signal there must be motion, and the interesting thing about it is it's not recovering very well. So you can see after the movement or whatever it was, it takes some time for it to recover. That could be like a disconnection or something. Something is wrong there. Yeah, those probably just motion. Anyway, sorry for that, for mentioning, but it's just a very bad file. Would be interesting to see what happens like after a longer period of time, if it stabilizes or not, because that's where you will be getting your baseline recordings from. If there's no more questions, I don't think so normally we're doing other things on this channel, some just organizational general things of what is it we are trying to do. So there is an about section, probably have to rewrite it. But yes, we're trying to democratize biomedical data, make it available for all. It doesn't say so, but sorry for the ads. Yes, the website is monetized. So go check it out. You will be learning and helping the project to be sustainable. But mainly I'm after comments. So if you tried any of the tools, please do let me know. There's another one. There's a bunch in the works. If you're watching the live streams in the videos, you will know. Quality tools. I'm not sure if that's a relevant ad. I mean, it's targeting me. So I don't remember searching for any quality tools. The one tool that we haven't actually published. So yeah, there is a lot of this no good type of. You can actually go to that URL. It will show you what it was. If it has a HTML. But yes, this EEG music, there's no link, so it's essentially like an unlisted. If you copy that, go to this site, hopefully it will start my, right, that's the EEG. Sorry, wrong one. Actually forgot what it's called. So currently we're doing the CardioQuest bot. It's essentially an AI, a machine learning thing that is playing this game. So hopefully soon it will be available for you to play with. It's currently working pretty well. I'm still testing it. And that's what it looks like. Close that. Yeah, that's what it looks like. So it's the same as this cardio game, which you have to play. So you have to click on abnormal ECG and do not click on the normal one to get your points, and try get there's no leaderboard, but I was able to get to 1000. So please do let me know if you're able to. How much did you score? And then there is this bot that is playing the game. So it's has an abnormality measure, and yes, we can just split it into, below, above 0.5, something reasonable. I think it's already doing it. Sorry, it's not 0.5, just to be 0.5. So 0.3 is more normal. I think normal should give me 0.1. Yeah, 0.1 is normal. So in theory, anything like above 0.2 should be considered abnormal. And then you measure its performance. So eventually you will have your score and the bot's score on the side for you to see which one's doing better or worse. So hopefully that will become available sometime soon. But go check out the website. There's many other interesting things that you might like or dislike. Please do, if you dislike it, do let me know how you think I should improve it. Because yes, it's work in progress. And also that's why the site is called Bionic Chaos. It seems to work pretty well now. The CardioQuest bot, the machine learning bot that is playing this game, it's fuzzy logic based. The parameters we're currently looking at this frequency, amplitude, and the number of positive and negative peaks, which is probably the most important in ECG. Then we have those 8 rules that essentially make the decision. So the example is if negative peaks, if there are too many negative peaks or too few, the abnormality is likely, so it's giving you like a 0.5 whatever value. And if the frequency is normal, then it's giving you unlikely. And these rules are all combined together. So ideally there will be some sort of, it's actually really hard to do or to review this thing. It's meant to be explainable AI. You can look at the combinations of 2 rules. So currently we have essentially 3-4 parameters. We have a frequency, number of positive peaks, negative peaks, amplitude, and the abnormality output, which is again, I mean, for the sake of this game, because it needs to make a yes/no decision. Most of the numbers are actually between so 0.1. Right, we can make it differently. So we can do, if this is say 0.2 or 0.15, because we get a 0.1 for normal ECG, then the abnormality is unlikely, so the answer will be normal, and anything else for possible or likely will be abnormal. So yeah, we can do it that way. But we might just continue testing this for a while until we make it available, say next week. So let me know if there's any questions. Check. Doesn't seem to be questions at the moment. By the way, I know someone might ask if the bot is potentially cheating, if it has some, insight that you might not have. So no, the bot is only seeing the waveform and not seeing anything else. So it doesn't have any labels or anything like that. So it's the same as you playing the game. You're just seeing the waveform. The bot is the same. In terms of improving over time, well, I mean, its performance already saturated like through the roof. So it's already does extremely well. So we might have to make the task harder by implementing more waveforms. So currently we only have 5 or 6. yeah, we have two variations of the QRS, no P wave, no S wave, no T wave. So we can generate more of these examples. Then the task will become harder, and then we'll see how well it performs. In terms of over time, there's only, yeah, some of the thresholds, the normalization of the thresholds is becoming better over time, yes. We'll look into it next week. Keep it sweet and short today. I'll see you next time. Bye.